Hello, this video is going to go over definitions associated with angles and discuss how to draw them. So before we begin, we have a x, y axis with a circle on it, right? And the circle is centered at the origin. So the quadrants of an xy axis is in the top right, you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4 on the bottom right. Your quadrants go in a counterclockwise order. Then we have a circle, right, which is 360 degrees. But we have 4 quadrants. So 360 degrees divided by 4 is 90. So we're going to start with 0 degrees. And then the next quarter is going to be 90 degrees. Plus another 90 is going to get me to 180. Plus another 90 gets me to 270. And then plus a final 90 degrees brings me to a full circle of 360 degrees. Now, usually when you draw an angle, you're always going to start at the positive x-axis. And this is going to be called your initial side because we will always start here. And we're going to go up and around in a counterclockwise manner in the direction that the quadrants go. Where you end is called your terminal side. So the initial side always starts in the same place, and then the terminal side ends depending on how many degrees your angle is. Now, that is when you have positive angles because we're going up and around in a counterclockwise manner. However, there are also negative angles. Like what happens if instead of going up and around, we go down and around in a clockwise manner. In that case, we would still start at 0 degrees. But if we're going downwards, because we're going opposite, we're going to say the first one going down is negative 90. Then another 90 degrees would be negative 180. Another 90 would be negative 270. And then finally, negative 360 degrees for a full circle going down and around. So positive angles go counterclockwise. Negative angles go down and in the clockwise direction. It is important to remember 0, 90, 180, 270, and 360. Because each of those angles begin at the start of each new quadrant, they are called quadrantal angles. So pause the video, take a minute, and copy down the vocabulary that we just went over. If you want to sketch an angle, first you have to label your quadrantal angles to help you know where what is on the circle. So now I have my quadrantal angles listed, and then we're going to start at the positive x-axis. Your initial side is always at the positive x-axis. Your terminal side, where the angle ends, is 240 degrees, which is between 180 and 270. But 240 is closer to 270 than it is to 180. So I'm going to put my terminal side closer to 270. You're not done yet. You need to show which way this angle opened. Did you go up and around or down and around? Because it's a positive 240, we start at the initial and go up and around and label it 240 degrees. The next one is negative 45 degrees. Because it's negative, I made my quadrantal angles going down and around. We're starting at the initial side, and now negative 45 is between negative 90 and 0. Actually, it's right in the middle of 90 and 0. So I'm going to put it right in the middle. Now you need to make your little arch inside. Because it's negative, we started at the initial and went down. And this is negative 45 degrees to label it. Now, later on, when we actually start doing problems with angles and finding sine of 240 or cosine of negative 45 degrees without a calculator, we can't actually do it without a calculator with such large numbers. So while you can't find sine of 240 degrees, we could find sine of a smaller angle. So instead of using such a large number, we're going to refer it to a smaller number. This is called a reference angle. So a reference angle is a positive acute angle in which theta, the angle measure, is between 0 and 90 degrees, and it's formed by the x-axis and the terminal side of the given angle. I'll explain what that means in a bit. It's easier to show it visually. So this problem is asking you to find a reference angle for each of the following. In order to find the reference angle, you're going to draw the original angle. We're going to start at the initial side on the positive x-axis. And again, 240, just like before, is between 180 and 270. And this is called sketching an angle in standard position because you're starting at the initial side of the positive x-axis. Now, 240 is too large for us to do computations with, so instead, we are going to go to the terminal side and compare it to the x-axis. So I'm starting at the terminal side, compare it to the x-axis, and from there, basically, I started at 240. I compared it to 180. So that means this angle measure would be 240 minus 180. It would be an angle measure of 60 degrees. So my reference angle for 240 is 60 degrees. And the math is going to be a lot easier for 60 degrees than it is for 240. So let's try the next one the same way. We're starting at our initial side. 315 is exactly in between 270 and 360. So this measurement is 315 degrees, which is far too large to work with. So we're going to start at the terminal side and compare it, and this is important, to the closer side of the x-axis. So I'm starting here. My closer x-axis is right up there. That means I started at 315 and I compared it to 360 degrees. So this angle measurement would be 45 degrees. So my reference angle is 45. And notice how both of these are less than 90 degrees. So keep in mind with reference angles, you always want to compare it to the x-axis. We never compare them to the y-axis. And it's always to the closer side. Also, if you have negative 60 degrees, the reference angle is positive 60 degrees. If you have an angle that is 70 degrees, it is its own reference angle. So take a minute and try to sketch on your paper each of the following angle measurements. So 30 degrees is between 0 and 90, but closer to 0. So here I have 30 degrees. Negative 330, actually because this is a negative, my angles should all be negative. There we go. And negative 330 is between negative 270 and negative 360, but closer to negative 360 degrees. Keep in mind, because it's negative, we are going down and around. And then 390 degrees is actually more than a full circle, right? Because a full circle is 360. So it's 360 degrees and a little more. In other words, we start at the initial, we make one full loop and a little more. And this would be 390 degrees. And notice how my little spiral went 360 and then the additional 30 degrees. Look at all these angles and see what you notice about all of them. Because what I notice is that they all end in the same spot. Actually, if you take a look, all of these, this is 30. This little measurement from negative 330 to 360 would be 30. And from 360 to 390, this spot is 30 degrees as well. So they end in the exact same position on your graphs. And that is called a coterminal angle. Co means they both share it, like co-workers work at the same place. Terminal, it means ending, right? So coterminal means they end in the same spot on the graph. So guys, coterminal angles are angles in standard position that have a common terminal or common ending side. And our three examples, negative 330, 30, 390 degrees that we just sketched, are coterminal angles. Now, think about it. If they end in the same spot, it's because they did one full revolution around the circle and ended in the same spot. So one full revolution of a circle is 360 degrees. So check it out. We start with negative 330 plus a full circle of 360 degrees will bring me to my coterminal angle of 30. If I take 30 degrees and add another full circle, I'm going to get to my next coterminal angle of 390. So whenever you think about coterminal angles, I want you guys to think about adding 360 degrees, going a full revolution around the circle and ending in the same spot. On the flip side, because you could have negative angles, you could also subtract negative 360 to find another coterminal angle. So for example, if you knew that, let's say you had an angle of 10, a coterminal angle of 10, if you add 360, would bring you to 370. So angle 10 and angle 370 end in the same spot when you sketch them in standard position. And that's all for this video.